actually does 4 different things. So we've already seen 2 out of the 4 things. All right, so we've seen it can make your graph open up, or it can make your graph open down if it's negative. What happens if we actually have a number in front? So this last part is called a stretch or compress. And this is, again, makes me think of that silly putty kind of thing. When you stretch it, it gets tall and skinny, versus if I compress it down, it gets shorter and wider. A little hint. Whenever you have an A, multiply the odd pattern by A to get your new pattern. Okay, so let's see what that actually means. Let me draw my graph. Okay, 4 is fine on this one. 1, 2, 3, 4. 1, 2, 3, 4. All right. So my first equation is going to be f of x equals 3x minus 2 squared minus 4. Okay. So let's go ahead and state our vertex just like normal. Change the sign in the parentheses, and this becomes positive 2. Keep the sign of what's after, negative 4. So 2 comma negative 4. So now is my A. So I'm going to take my normal 1, 3, 5, 7 pattern, but I'm going to multiply it by A, which is my number in the very front, which is a 3. So multiply each of these by 3, and this is your new pattern. 3, 9, 15, 21. Okay, so I am now going to go over to my vertex. So 2 comma negative 4. 1, 2, 3, 4. Okay, so that's down here. And I'm going to use my new pattern. So my first number is 3. So for my vertex, I'm going to go up 3. 1, 2, 3 over 1. Next number is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just going to kind of make a reference point up there. I'm not going to make my graph all the way, but I just want you to see how tall and skinny it's getting. So go back to your vertex and repeat for the other side. So I'm going to go up 3, 1, 2, 3 over 1, and up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1 is like here-ish. And so my graph, see how I'm not actually using those points? I'm kind of just using them as like a reference of where I'm going. But see how it's much taller and skinnier than all of our previous. Hey, actually that looks pretty good. Kind of you can see the difference, how it's much skinnier. Okay. So that is called a stretch. And then the other one is called a compression. So f of x equals 1/2 times x plus 2 squared minus 1. Okay, so again, we need to state the vertex. All right. Change the sign of the parenthesis so it becomes negative 2. Keep the sign that's after the parenthesis. So negative 2, negative 1. And my pattern, ladies and gentlemen, take your 1, 3, 5, 7 and multiply them all by 1/2. Okay. Now, do not simplify any fractions on here. If you do, your pattern won't work. So 1 times 1/2 is 1/2. 3 times 1/2 is 3/2. 5/2. 7/2. Okay. So my vertex is at negative 2, negative 1. That is here. And look at my pattern. It wants me to go up 1/2. over 1. Okay, so a hint that I've learned is I'm counting by halves. So I'm going to go over here and I'm going to mark what is halfway between my lines. Okay, I only care this direction because my graph is going to go up. Okay, if this was a negative, then I would have done all these markings down here and marked them off. So how does this work? Here's my vertex. My pattern says to go up half. If I go up half, that is here over 1. Okay, so see how I'm not on the line? I'm halfway. So that's where these little markings come in. Next is 3 halves. So I'm really counting these little markings. So 1 half, 2 half, 3 halves over 1 would be here. Next is 5 halves. 1 half, 2 half, 3 halves, 4 halves, 5 halves over 1. Okay, I don't think I have enough for 7 halves, so I'm going to go back to my vertex, repeat for the other side. So again, I'm only going up 1 half over 1. Next on my pattern is 3 halves. So 1 half, 2 halves, 3 halves over 1. And then 5 halves. 1 half, 2 half, 3 half, 4 half, 5 halves over 1. Connect the dots. And what you'll hopefully notice is it's a much wider looking graph. So let's look back from before. So this is what our normal graphs look like. And so this one, notice it's shorter and wider looking. So that is what happens when we multiply by a number between 0 and 1. Okay, so let's kind of summarize this and then I'll have you guys try to, and we're done for the day. Okay. When A is greater than 1, the graph gets taller and more narrow. Oops, running into the hole. Okay, so that was our black one. And then when A is between 0 and 1, so let's make a note of our words, that's our math. Between 0 and 1, the graph gets shorter, and wider. Okay? All right, so I'm going to have 2 for you to try, and then that is it for notes today. So let's set this up. Okay. You want 5 marks? 1, 2, 3, 4, 5. 5. Okay, so your 2 graphs are going to be f of x equals -2 times x plus 3 squared plus 4. And your other one is going to be f of x equals 1/2 x minus 1 squared plus 2. Okay, take a moment and pause the video and go over this now. Totally see that in the frame. Didn't realize that. See how you do. Why did I write that vertex in? Sorry. See what you can do. Okay, let's see how you did. So our first graph, you should have a vertex of -3, +4. Okay, that is up here. And it has a stretch factor of -2. So when I multiply, I'm going to get -2, -6, -10. So I go down 2 over 1, down 6 over 1. That's all I can fit, so I connect my dots after I've done both sides. 1/2. Okay, it's the same pattern as before up here. So my vertex was at 1, 2, and then I went up. Notice I drew my half markings. I went up 1/2 over 1, up 3/2, 1, 2, 3 over 1. Technically, I did the same for both sides, and then I connected in a U-shaped wider graph. Okay. Last thing I would like you to do on your notes, okay, is down at the very bottom, kind of nice and big. It can be over on the side, but somewhere at the bottom of your paper, I would like you to write a really big number, 1 through 5. How are you feeling about these notes? And please put a big circle around it. That way I can get some nice feedback and see how you feel since my power is up. Okay. All right. Make sure you submit these, you guys, the same day as live class, even though we don't have live class, so that I can mark you present for attendance.